Hi, fifth graders. How's it going? It's Mrs. Bandy checking in for another week of math. I'm coming to you live from my math studio, aka the spare bedroom at the Bandy household. How are you guys doing this week? I hope you're doing well and you're getting outside, washing your hands. I have some really big news for you before we get started with math. My class, you know how much I love to drink Diet Coke, right? Well, Mrs. Bandy has stopped drinking Diet Coke. It has been a whole week. Can you believe it? I know, Keegan, it's amazing, right? It's a shocker. So I'll keep you updated on that hot news there. All right, let's get started with our line plots. This week, we're going to be talking about line plots. Line plots are used a lot in the real world, in science, in the medical field, if they're graphing something, business, marketing, accounting might use a line plot. Those are just some examples of where you might see one in the real world. Let's take a look at some examples. On the screen, you're going to see two examples of line plots. These line plots and all line plots have several things in common when we're interpreting the data. The first thing that every line plot should have is a title. You can see in this line plot, the title is orders for cheese. That means that all the data that's in this line plot has to do with the number of orders for cheese. And in this line plot, it's times in the 40-yard dash. That means that all the data in this line plot represents times in a 40-yard dash. Also, a line plot includes labels. You're going to see that the number line is labeled with, in the first one, amount in pounds. That means that we're talking about the orders for cheese are in pounds. They're not in ounces. They're not in tons. It's pounds of cheese. And in the second line plot, the time is in seconds. That means that all of the times recorded for the 40-yard dash are in seconds. It's not minutes. It's not hours. It's seconds. You're also going to see that the line plots have data. Sometimes the data will be in the form of a fraction. Sometimes the data will be in the form of a decimal. The data can also be in the form of a whole number. In the orders for cheese line plot, we have fractions representing our data. That means that let's take a look at this 1/4. There's two x's over top the 1/4. Those two x's represent 2 orders of cheese in pounds. That means that there were 2 orders that were 1/4 pounds. If we went over to, let's say, the 1 1/2, how many x's are over top of the 1 1/2? Right, 1x. That means that there was 1 order of cheese that was 1 1/2 pounds. Now let me ask you this. Do you see any x's over 1 1/4 pounds? No. So what does that mean if there aren't any x's over it? Right, that means that there weren't any orders for cheese that were 1 1/4 pounds. Now, let's take a look at the times in the 40-yard dash. You can see that now we don't have x's. This time we have dots. It's the same thing. You can put an X or you can put a dot. Personally, I like the X's because I feel like they stay separated as you're building your line plot. So let's take a look if we were going to read this line plot. I circled one dot over 6 8/10. No, it is not 6.8. We are mathematicians, so remember that we have to read those numbers properly. So there's one dot over 6 8/10. What does that one dot represent? Take a minute, think about that in your head. Okay, so what does it represent? Yell it out to the computer. Yeah, right. So it represents that there was one time recorded in the 40-yard dash that the 40-yard dash was run in 6 8/10. That means that there was one recording of that. Now, let's go over and let's take a look at this one. So, how many times in the 40-yard dash were recorded for 7 1/10 seconds? 5, right. How did you get that 5? What did you do to figure out that there were 5? Right, you counted the dots. There are 1, 2, 3, 4, 5 dots over top the 7 1/10 seconds. So that means that there are 5 people that ran the 40-yard dash in 7 1/10 seconds. On the screen, you're going to see the line plot from the previous slide. I wanted to show you how we got from the set of data to the line plot. You're going to see on the screen that this is what we started with. And today we're not going to be asking you to build any line plots. We're just going to be asking you to interpret them, to read them and answer questions about them. Creating the line plot will come later. But I wanted to show you how we got from the information to the line plot. So you see I drew an arrow and it says Mr. Rice's students ran a 40-yard dash in the following times in seconds. 6 8/10, 7 3/10, 7 1/10, and so on and so forth. That data was taken and it was put into your line plot. And I just wanted you to see that comparison of how we had the data and how it got into the line plot. Okay, the line plot is back on the screen, same one from the previous page, times in 40-yard dash. Let's pull apart this line plot and let's interpret some data and answer some questions about the line plot. First question, how many race times are recorded? Now, if we want to know how many race times are recorded, what do you think we need to do? So yeah, you're right. We need to count all of the dots. In this case, they're dots, they're not X's, on the line plot. So we've 1, we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that means that there are 16 race times recorded. So let me just get rid of all of these dots so that we can move on to the next question. So that means that there are 16 race times recorded on this line plot. All right, let's take a look at the next problem. Which time occurred most often? So when we see those words most often, we're referring to on the line plot what time comes up most frequently. And we would be able to see that by the most number of X's or dots above that value. So for example, if we're looking at this question, which time occurred most often, we would want to look at which number has the most dots above it. And right now, it looks like 7 1/10 has the most dots above it because it has 1, 2, 3, 4, 5. And it actually goes up higher than the rest of the data. So the time that occurred the most often would be 7 1/10 seconds. All right, take a look on the screen. I have a new line plot posted for you. This one's titled Goals Scored. Let's dig in. Let's interpret some data for this line plot of goals scored. And let's answer a couple questions. How many soccer teams scored 3 goals? Now, I know because there's a label right here that says number of goals scored, that each of these numbers on the number line represent the number of goals scored. So that means that how am I going to figure out how many teams scored 3 goals? I want you to pause the video, take a minute, think about that, write down your answer on a separate sheet of paper. Okay, what did you get? How many soccer teams scored 3 goals? Right, if you said 2, you would be correct, because looking here on my line plot, here is 3 goals, and how many dots are above the 3? 1, 2. So that would mean that 2 teams scored 3 goals. All right, let's take a look at our next question. It says, how many teams scored more than 5 goals? That means we have to look at that. What does that more than 5 goals mean? Right, that means that they scored 6 goals, 7 goals, or 8 goals, because our line plot, our number line, only goes up to 8. So pause the video, take a look at the line plot, write on a separate sheet of paper how many teams scored more than 5 goals. All right, what did you get? How many teams scored more than 5 goals? Well, let's take a look at our line plot. Well, more than 5 would be, let's start at 6. So how many dots do we have above the 6? Right, we have 3. And then the 7. How many dots do we have above the 7? We have 1, 2, 3, 4, 5. So there's 5 there. And then 8. How many dots do we have above the 8? We have 1 dot. What am I going to do with all of those numbers? The 3, the 5, and the 1. Right, I have to add them together. So 3 plus 5 equals, yell it out, 8. And then 8 plus 1 equals 9. Right, so that means that there are 9 teams that scored more than 5 goals. Okay, let's take a look at the line plot on the screen. Same one from the previous slide. We're going to take a look at a couple questions. I'm going to have you do a little work on your own and then come check back and we can compare answers. Let's take a look at this question. It says, what was the greatest number of goals scored by a team? I want you to think about that. Think about the number of goals scored by a team and what would be the greatest number, so the largest number of goals scored by a team. And then let's look at this problem. How many teams scored only 2 goals? So let's unpack that. That means that I want to know how many teams, the number of teams that scored only 2 goals. Not 0, not 1, not 8, not 7, 2 goals. Take a couple minutes, pause the video, and come up with those answers on a separate sheet of paper by yourself. And then when you're done, come check back in with me and we'll compare answers. So go ahead and pause now. All right, what was the greatest number of goals scored by a team? What was it? It was 8 goals, right? Is that what you got? Comparing? That was the greatest number of goals scored by a team. Now, how many teams scored only 2 goals? That means that they only scored 2 goals, no more, no less. So how many teams was that? Right, that was 3 teams that scored only 2 goals. And I know that because I'm looking at my number 2, and there are how many dots above the number 2? 1, 2, 3. So that's how I got my 3 teams. All right, let's take a look at this last problem, and then I'm going to set you free to do a little work on your own. It says, what is the difference between the greatest and least number of goals scored? So if I'm finding the difference, what operation am I doing? Am I adding, subtracting, multiplying, or dividing? Right, I'm subtracting. So what is the difference between the most amount of goals and the least amount of goals scored? So pause the video, take a minute to find your answer on a separate sheet of paper, and then we'll come back and we'll compare. All right, so what is the difference between the greatest and the least number of goals scored? You should have said what? Right, 8 goals. All right, 5th graders, next steps for math. Next thing you're going to do is you're going to go ahead and you're going to log into Envision. Remember, you go to start.hcps.org. You put in your login information, which is first and last name at student.hcps.org. And then your password is love, and then your lunch pin number. Then you're going to see that I assigned for you for this week a playlist. You had the same thing last week. I put all of your assignments in the playlist to make it easier for you to access so that you don't have to continuously get out of something in Envision to find something else. So everything's here for you. The first thing you're going to see is the practice. This, I want you to do problems number 6 through 8, so 6, 7, and 8 on the practice. Then you're going to go into the practice buddy, which is right there in the playlist for you, and you're going to solve the problems on the practice buddy. Remember, the practice buddy, you're going to hit submit at the end on the review screen, and that will be submitted directly to myself and to your homeroom teacher. I've also posted in our Padlet a link for a reteach video in case you need more support with interpreting line plots. And I've also put a link in our Padlet for our weekly riddle. Remember, the reteach and the puzzle or the enrichment are optional. Those are things that you can do if you want to after you've completed all of your required math work and all of your other required work. As always, if you need anything, do not hesitate to reach out to myself or to your classroom teacher. Good luck.